The trigonometric ratios of 60 degrees, which is pi over 3, 30 degrees, which is pi over 6, and 45 degrees, which is pi over 4, can be found as exact values in the form of fractions and surds. These values are given in formula and tables. So 60 degrees and 30 degrees. Consider the equilateral triangle ABC, so ABC, with sides of length 2. So we have 2 units, 2 units, and 2 units, which is shown opposite. If D is the midpoint of BC, so this is BC, and D is the midpoint, then BD is going to be equal to 1. So from B to D, we have 1 unit. If from B to C is 2 units, then from B to D is 1 unit, because D is the midpoint of BC. And likewise, DC would also be 1 unit. The angle ABD is going to be 60 degrees. So ABD is going to be 60 degrees, as all angles in an equilateral triangle are 60 degrees. So 180 divided by 3 is 60, so we've got 60, 60, and 60. AD is perpendicular to BC. So AD is perpendicular to BC. And by congruent triangles being identical triangles, so 3 equal sides, 3 equal angles, the angle BAD is equal to 30 degrees. So BAD must be 30 degrees, because this line AD, which is perpendicular to BC, has cut the equilateral triangle in half. So if this angle here is 60, then half of that is 30. So ABD is congruent to ADC. They're identical. So the angle BAD is 30 degrees, and this is from the angle sum in a triangle. So we know that this angle is 60, this angle is 60, this angle is 60. Half of 60 is 30. And another way we could know that is these 3 angles need to add up to 180. If this is perpendicular, then this must be 90. And 180, take away the 90, take away the 60, also leaves us with 30. AD is equal to root 3. So AD is going to be equal to root 3 using Pythagoras' theorem on ABD. ABD. So ABD is a right angle triangle. 2 is the hypotenuse, or AB is the hypotenuse. So that's going to be labelled as C. And then I can label the other 2 sides as A and B. It doesn't matter which way I do them. And we know that Pythagoras' theorem tells us that C squared is equal to A squared plus B squared, where C is the longest side, C is the hypotenuse. So we have the C is going to be 2, the A is going to be 1, and the B, we are eventually going to figure out that it's root 3, but the B we can just label as X for now. So we get 2 squared equals 1 squared plus X squared. 2 squared is 4, 1 squared is 1. So we're going to minus 1 to both sides, and 4 take away 1 is 3. And if 3 is equal to X squared, then X is equal to root 3. So that's how we got AD to be root 3. So AD is equal to root 3 using Pythagoras' theorem on ABD. Thus, cos of 60 degrees is going to be a half. So cos, we know, is really cas, so cos equals A over H. So cos of 60, so this is the angle. So cos of 60 equals A over H, so the adjacent over the hypotenuse. So 1 over 2, because this is the adjacent to 60 degrees, and this is the hypotenuse. So cos of 60 degrees equals 1 over 2. Cos of 30 degrees is going to be root 3 over 2. So again, cos is equal to A over H, so cos of 30 degrees is going to be equal to the adjacent, which is going to be root 3, over the hypotenuse, which is 2. So cos of 30 degrees is equal to the adjacent, which is root 3, over the hypotenuse, which is 2. So cos of 30 degrees is equal to root 3 over 2. Next we have sine. And we know from SOHCAHTOA, sine is equal to O over H, the opposite over the hypotenuse. So sine of 60 is equal to O over H, which is the opposite, which is root 3, over the hypotenuse, which is 2. So sine of 60 equals root 3 over 2, the opposite over the hypotenuse. Sine of 30, so here's 30, again is equal to the opposite, which in this case is 1, over the hypotenuse, which is 2. So sine of 30 is equal to 1 over 2. And then we have tan. So we know from SOHCAHTOA that TOA represents tan, which is equal to O over A, the opposite over the adjacent. So tan of 60, so this is 60, so TOA, so tan is equal to opposite over adjacent, so the opposite is root 3 over the adjacent, which is 1. So it's going to be tan of 60 equals root 3 over 1, which is just going to be root 3. And then tan of 30, so this is 30 degrees. So again, tan is equal to opposite over adjacent. The opposite is 1. The adjacent is root 3. So tan of 30 is equal to 1 over root 3. 45 degrees. Consider the isosceles right angle triangle ABC, so ABC, with the angle ACB equaling 90 degrees. So ACB is 90 degrees. So it's a right angle. AC is 1 unit. From A to C is 1 unit. BC is 1 unit. BC is 1 unit, so it's an isosceles triangle. Then the angle ABC is 45 degrees, as is the angle BAC. So ABC, 45 degrees. BAC also 45 degrees, because 180, take away the 90, leaves us with 90, and divided by 2 is 45. So 45 and 45. So the angle ABC is equal to 45 degrees, and the angle BAC is equal to 45 degrees, as the base angles of an isosceles triangle are equal. So they're both 45 degrees, and in this case add up to 90 degrees. Also, by Pythagoras' theorem, the distance from A to B is root 2. So I'm going to label my triangle ABC, with C being the hypotenuse, the longest side. Then I write out my formula, c squared equals a squared plus b squared. I'm trying to show that this is root 2, so for the moment I'm going to label it as x. So I have x squared equals 1 squared plus 1 squared. So I have x squared equals 2. So I have x is equal to root 2. So that's where the root 2 comes from. So we're going to use our 45 degrees. It doesn't matter which one we use, but I'm going to go for this one here. And we're going to show that cos of 45 degrees is equal to 1 over root 2. So again, we're going to use SOHCAHTOA. So we're going to start with cos. So we know that Ka stands for cos is equal to adjacent over hypotenuse. So the adjacent to 45 degrees is going to be 1. And the hypotenuse to 45 degrees is root 2. So cos is equal to the adjacent over the hypotenuse. So cos of 45 degrees is equal to 1 over root 2. Next we're going to look at sine. So SOS stands for sine is equal to opposite over hypotenuse. So the opposite of 45 degrees is 1. And the hypotenuse is root 2. So if sine is equal to opposite over hypotenuse, then sine of 45 degrees is equal to 1 over root 2. And next we're going to look at tan. So tan is going to be TOA. So TOA represents tan is equal to opposite over adjacent. So the opposite of 45 degrees is 1. And the adjacent of 45 degrees is also 1. So if tan is equal to opposite over adjacent, then tan of 45 degrees is equal to 1 over 1, which is 1. So this is a summary of our ratios. So cos of 60 degrees is a half, cos of 45 degrees is 1 over root 2, and cos of 30 degrees is root 3 over 2. Likewise, cos of pi over 3 is a half, cos of pi over 4 is 1 over root 2, cos of pi over 6 is root 3 over 2, and so on. Sine of 60 degrees is root 3 over 2, sine of 45 degrees is 1 over root 2, sine of 30 degrees is a half. Tan of 60 degrees is root 3, tan of 45 degrees is 1, tan of 30 degrees is 1 over root 3.